This is Geometry Unit 1 review for the test. We're looking at the midpoint formula, x1 plus x2 over 2, comma, y1 plus y2 over 2. Notice that that's a coordinate point. And then distance formula, it is subtraction. Here it was plus, here it's subtraction. You subtract the two x's, square them, subtract the two y's, square them. Add the two sums together and take the square root. So we're looking for three non-collinear points. 3 points that are not on the same line, non-collinear. So several different choices. We could do H, A, C. H, comma, A, comma, C. Definitely not on the same line. 3 coplanar points, 3 points that are on the same line. We are looking for 3 points that are going to make a triangle. So we could say HAD. Two intersecting lines. We have line AB, so we put the arrow over it, and we have line CE. There's several different ways we could name those lines. This is one of them. 3 collinear points, 3 points that are on the same line. We have 2 choices. Looks like we have 3 points. So we have points A, comma, D, comma, B. 3 points on the same line. 1 pair of opposite rays. We have 2 sets of opposite rays. We have it from D to A, D to B, or D to C, D to E. Your choice. But I'll say DA with the arrow over the A. That means it's coming from point D over point A. And then we go from the same endpoint over B. So DB. Those are called opposite rays. Okay, we have a plane. You name a plane using 3 points. So 3 points, we can use HAD again as a plane, or we can use HAB, whichever we like. It's just you wouldn't want to pick the 3 points on the same line. You don't want to pick collinear points. It should be 3 points that make a triangle. 2 line segments. Well, there's a whole bunch of line segments. We have segment AD. We have segment CD. There's a whole bunch of line segments. Segment AB. You could do that one. Give another name for line AB. So any 2 points along that line. So we could call it DB with the line segment above it. Next, we notice that we're trying to solve for the variable and then find the measure of the segments. So here I recognize that GE plus EM is going to equal the whole length, which is GM. So the small part plus the small part equals the big part. So then we substitute in our values. We collect our like terms. Here we have 4 x's and 3 x's, so that's 7 x's. Positive 9 minus 2 is positive 7. And then we subtract 7 to take it down to 21. And then divide by 7 gives us 3. So that's the value of x. Now if we were to plug that in, we would get 4 times 3 plus 9. 4 times 3 plus 9. That's 12, and 9 would be 21. Plug 3 in here. 9 minus 2 would be 7. So 3 times 3 minus 2 equals 7. So those are two answers, and x was 3. Here we know the two segments are congruent to each other. If they're congruent to each other, they're going to be equal to each other. And we can substitute in our 5x minus 8 and our 3x plus 20. We can make tick marks on the segment because we know that they are congruent to each other. Tick marks indicate that they're the same size and shape. That's 2x. Here I'm going to add 8, and add 8 gives me 28. Divide by 2 gives me 14. So I'm going to plug in here and say 5 times 14, not 5 times 2, but 5 times 14 minus 8. That's 70 minus 8. That is 62. Now this should be 62 also. When I plug in 14 plus 20, I'm getting, that would be 30, and 12 would be 32, plus 20 more. Let's do that math again. That's 30 plus 2 would be 42. 42 plus 20 gives me 62. So they are both 62. Here we're looking for the length of CD. One way we can do CD is to use the distance formula. CD equals, let's do the distance formula right here. It's written at the top of your page also. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. This is one way that you could do the calculation. So I'm going to take my x value. We can call this x1, y1, x2, y2 if you like. So we're taking x2 minus x1 and adding that to y2 minus y1 . So when we have 3 minus a negative, that's actually 3 plus. Don't forget your square. 4 minus a negative actually is 4 plus. That gives us 7 squared plus 7 squared. Now we cannot take the square root of that. We have to do the individual calculations. Because of the plus, we can't get involved with that yet. We've got to say 49 plus 49, which is going to be 98. And it says round to the nearest hundredth, so we're going to use a calculator for that one. So the square root of 98 gives us 9.89. So that's going to round up to 9.9. Approximately 9.9. Now for our other segment, we could do the same thing. We could use distance formula. But here I'm going to try it in a different format. You can always do this when it's on a grid. This length is 2. You don't have to worry about positive or negative. This length is 3. So we're working with the Pythagorean theorem. We're saying that AB, and that's a quantity squared, is equaling 2 squared plus 3 squared. So AB squared equals 4 plus 9. AB squared equals 13. So AB itself, we're going to take the square root of 13, and using a calculator, the square root of 13 is 3.6. That means 3.6 times 3.6, if we raise this to the second power, you should get exactly 13. Now, if I use my rounded answer and I square that, that's not going to be exactly 13, because that's a rounded number. And the question is, are they congruent to each other? And we can say no, AB, congruent, not congruent to CD, because they are not the same length. To be the same size and shape, you have to be the same length. So if you're not the same length, you're not going to be the same size and shape. Okay, Evan's house is located at 4, 3. So I'm going to put in our grid. It looks like it's kind of a dark line here and here. That's my XY axis. I'm doing 4. 1, 2, 3, 4. 1, 2, 3. That's Evan's house, so we're going to make that E. We have Ryan's house. 1, 2, 3, 4, going up 1. That's Ryan's. And then we have the bus, which is at -1, -3. That's the bus. Now we're trying to figure out who has to go the furthest to get to the bus. Okay, clearly it looks like Evan's got to go longer, but we need to support it using a formula. So I'm pretty sure we know the answer, but we need to support our work. This is point 4, 3, and the bus stop was at -1, 3, -1, -3. So we can use our distance formula again. dB is going to equal the square root of x2 minus x1 and y2 minus y1. Notice how I do that. I have to pick the x's together, then I pick the y's together. I don't pick the numbers next to each other. So that becomes 4 plus 1 squared and 3 plus 3 squared. That becomes 5 squared and 6 squared. That is 25 plus 36. That is 61. Square root of 61. We could do a decimal off of that. Square root of 61, 7.8. Now we can try the other one. We're going from Ryan's house. Ryan lives at -4, 1. So we're doing RB. So that would be -4 minus a -1 squared plus 1 minus a -3 squared. -4, negative and a negative make a positive. 1 plus 3. Notice I use my square root all the way through the problem. So this becomes -3 squared. This becomes 4 squared, which is 9 and 16, which of course is 25, which can simplify to be exactly 5. So use a formula from this unit to decide who walks further. So we know that Evan will walk further, because he is 7.8. Point M is the midpoint. If you look closely, we have a tick mark there and we have a tick mark here. So that helps us also indicate that those are the same measurement. We're going to know that VM is congruent to MW. If they're congruent to each other, they are equal to each other. And we can substitute in our values and collect our like terms. So I subtract over my 6x, I add my 6. Those cross out. I get x equals positive 2. Now I'm supposed to find out the length of VM. So VM equals 7 times 2 minus 6. That's 14 minus 6. That should be 8. Find the coordinates of the midpoint. Now the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. Well, the coordinates themselves, this should be x1, this should be y1, this is x2, this is y2. So 0 plus 0 over 2 and 0 plus a negative 12 over 2. That makes that 0 over 2 and negative 12 over 2 gives us 0, negative 6. That would be the midpoint between A and B, halfway in between. Use the diagram to find the measure of the angle. State what type of angle is being formed. Is it acute, obtuse, or right? So, CAF, use your eyes. CAF, trace it out with your pencil, trace it out with your finger, at least your eyes. CAF. Oh boy, this is going to be tough. Let's take a look. So this is going from 80. And this one's ending at 55. So if you put that in absolute values, that's a way that we can measure a distance. If you know the endpoints, not coordinates, but if you know the endpoints, that's what we need. So this is coming out to be the absolute value of negative 75. And if you recall, absolute values force it to be positive. So that is 75 degrees. That would be an acute angle. BAD. BAD. Well, one way you could do that is to say 120 minus 80, 180. That gives us negative 60, which is 60. So again, that is an acute angle. That's less than 90 degrees. EAD. EAD. Notice that it's starting here and it's swinging all the way across. So the angle is the whole thing. That's 180 degrees. That's called a straight angle. And EAB, starting at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120 to get to B. 120 degrees, which is an obtuse angle. Last two. Notice how this one here is a straight line. Just like our straight angle here, this essentially makes a straight angle. So we know that this angle, ABC, is 180 degrees. Therefore, the measurement of angle AB D plus the measurement of angle DBC has to equal this measure of angle ABC. So 5x plus 10 and 2x minus 5 have to add up to equal 180 degrees. A lot of people miss that 180, so pay attention to that straight line. It's an angle that includes that whole straight line. So this becomes 7x. This becomes 5, positive 5. Subtract 5 more. So 7x equals 175 divided by 7. Now, I don't know what 175 divided by 7 is. But I do know that 7 goes into 17 2 times. That's 14. And there would be 3 more to get up to 17. And 7 goes into 35 5 times. So I now know that x is a value of 25. So we want to know the measurement of ABD. So we're going to say 5 times 25 plus 10. That's 125 plus 10. That's 135. That is the measurement of angle ABD. And then final one. We know that all 3 angles add up to be a straight line. So the measurement of angle POS, that's this one. Use your eyes, use your pencil, plus the small one in the middle, the measurement of angle SOR, plus the small one on the side, the measurement of angle ROQ, equals the measurement of angle, the big angle, POQ. So we have 5x plus 4, we have x minus 2, we have 3x plus 7, and the whole big angle is 180 because that is a straight line straight across, and those angles are being half of a circle. So we have 5x and 1x plus another 3 x's. 5, 6, 7, 8, 9. So that's 9x. Here's 4. Take away 2, which is 2. And 7 makes 9. Together, that makes 180. Now we bring this down. 9x equals 171. Divided by 9. I'm not sure what 171 divided by 9 is. But I know that 9 goes into 18 one time. With 8 left over, goes into 81 9 times. So x is 19. And the measurement of ROQ is 3 times 19 plus 7. So if this was 20, it would be 3 times 20, which is 60. But take away the 3 extra singles, so that's 57. 57 plus 7, and that is 64 degrees. Good luck. Just kidding. There's another page. All right, we got a bisector. So the bisector means it cuts it in half. So we have the measurement of angle ABD equaling the measurement of angle DBC. If we have DB as an angle bisector, that makes this angle the same as that angle. And notice those are called tick marks for angles when you put the curve inside of it. So this is 2x plus 24. This is 3x minus 12. They're the same measurement, but there's different ways to calculate it. Just like if you're making change for a $20 bill, you could use 2 10s, you could use 5 4s, you could use a 10 and 2 5s. Lots of different ways you can add up to be the same number. So this is 36. So now we're supposed to plug it in, and we have 2 times 36 plus 24. That's 72 plus 24. That's 96. Each angle would be 96. Over here, we're looking at ABD. If we know that BD bisects it, that means it cuts it in half. So the measurement of ABD equals the measurement of angle DBC. So that makes 18 minus x is going to be the same thing as 36 minus 3x. I'm going to add my 3x across, but remember I'm taking 1 away, so that's 2x. So I'm going to minus my 18, and when I do that from 36, I actually get 18, and that gives me 9. So since the two angles are the same, we have 18 minus 9, which is going to be 9. They should both be 9 degrees. Okay, what I notice is when I plug 9 back into here, I'm not getting, or yes, 9. I'm not getting 9. 26 minus 3 times 9 is 27. That's actually -1. Something's wrong. What is wrong? So I come up here and look at my answer. 18 minus x equals 26. Did you notice that? That is 26. Did you copy me too much? Pay attention to what's going on. Copying doesn't help. So we're going to subtract 18 from 26. So that's going to be the number 8. So that's going to give us a value of 4. So here we're going to say 18 minus 4, which gives us 14. That might be a better answer. Let's see what happens when I test it in the other one. 26 minus 3 times 4, 26 minus 12 is 14. It worked. Here we're going to use the Pythagorean theorem. Remember, the hypotenuse is always across from the 90 degrees. The leg and the leg are always perpendicular to each other in a right triangle. So we have hypotenuse squared equals leg squared plus leg squared. That's 24 squared equals a squared plus 22 squared. You can use 24 squared, 576, a squared, and then 22 squared. So I'm going to subtract the 484. So if I can cursor up, that's the cool part about this calculator, and minus that value. I get 92. A squared equals 92. Now I need to take the square root. Okay. So when you take the square root of that, you're going to see, following the directions, that we're supposed to have this as radical form. So we don't want decimals. I'm going to notice that 92 is 4 times 23. When you take the square root of a squared, you get a. I know the square root of 4 is 2. So that's 2 root 23. That's the length of A. Let's try this one over here. 6, 9, and blank. Again, this is the hypotenuse. You have to have the unknown on its correct location. So you don't always just put the unknown on the outside. So here we put the unknown, because that's what we don't know. Here we put the unknown in the leg location. The hypotenuse is unknown, but we know the leg squared plus leg squared. That's 36 plus 81. That's 8, 9, 10, 11. And the 6 and 1 makes 7. So we have 117. So we see that the hypotenuse is going to be the square root. I need an equal sign in here. Is going to be the square root of 117. And 117 can be broken down into 9 times 13, which is 3 root 13. That is simplified radical form. No decimals when it says simplified radical form. You want the answer in a radical. Here we have a 25-foot ladder. It's slanted here. There's the ladder. It is 24 feet above the ground that it's touching. So 24 feet above the ground. It's a 25.5 foot ladder. And the question is, how far is it from the side of the house? Okay, the house is standing straight up, so we can assume this is at 90 degrees. So we have the hypotenuse squared equals the leg squared plus leg squared. So 25.5 squared gives us 650.25. 24 squared is 576. So we minus 576. So I'm going to take my answer from up here and subtract the number from above it. And that gives me 74.25. And we can round to 1 decimal spot. So it's okay for us to take the square root. Just with our calculator. It's the square root of our previous number. And that comes out to be 8.6. 8.6 is approximately x. And the last few questions. This is called, we're trying to determine what type of triangle we have. So this is the converse of the Pythagorean theorem. That would be if you have a squared plus b squared that equals c squared and they equal, then it's a right triangle. Okay? If we know that the longest side, I'll put some notes in here for you. The longest side has to be smaller than the sum of the shorter sides. The longest side has to be shorter than the sum of the shortest. So here, when we take the longest side, we see that that is smaller than 11 plus 24. 26 is smaller than 35. So yes, it makes a triangle. Now, if it makes a triangle, then we can take, and let's put in our notes here again, c squared, if it is greater than a squared plus b squared, we have an obtuse triangle. If c squared is less than a squared plus b squared, we're going to have an acute triangle. And by the way, if you have c squared that equals a squared plus b squared, then of course you have a right triangle. So those are the basic notes. So we're going to come over here and say 26 squared, compare that with 11 squared and 24 squared. So we can use some help with our calculator. You should bring a calculator to the quiz. So we get 676, 11 squared. We're comparing that to 121 and 576. So that's 676 and 697. So we notice that the c squared is less than. So we call that an acute triangle. C squared is less than. You got to put the c squared, the largest side, on the out left side. C squared is less than. Over here, we see that 72 compared to 48 and 20. 72 is still bigger than 68. Not a triangle. It's not a triangle, so you can't even calculate it because it doesn't make a triangle. Their sides are not long enough. These sides would not touch. If you swung it, they wouldn't touch. They wouldn't fill up the whole thing. 72 is too long. All right, over here we see 8.1 is less than 5.8 and 2.4. That's 7. 8.2. 8.1 is less than 8.2. So it is barely less than. So let's do it. 8.1 squared. Compare that with 5.8 squared and 2.4 squared. 8.1 squared gives us 6561. Compare that with 5.8 squared. Not inverse. Okay, let's try that again. 5.8 squared is 3364, and 2.4 squared. So we add those two numbers together. 33 plus 576. And we clearly see that 65.61 is much bigger than 39.4. So this is going to be an obtuse triangle because c squared is greater. All right. Now, that is good luck, everybody.